Hello students, this is Steve Larson. This will be the first of our video lectures. We'll have several of them during the semester. I hope you don't get too tired of them, but this is the only way we can do this effectively, given that most of you are remote, and of course the class is designated as a remote class. Today we're going to go start on Chapter 1, which is about the introduction to data. Before I start on that, I wanted to just take a moment and tell you that as a called missionary here into Hawaii, I wanted to take a moment and share my testimony that I know the gospel is true, that the Church of Jesus Christ is the Lord's kingdom here upon the earth. And I'm grateful for the revelations we have received. We have a prophet on the earth, that the Lord has given us the scriptures. And I know that the Book of Mormon is true. And I also am grateful for my Savior, Jesus Christ, and all that He has done for each and every one of us. Having said that, we'll now move on into our topic, statistics, but I definitely wanted to take the time to share that with you. I am going to start our PowerPoint presentations. You'll see a copy of these out on Canvas. When you get this, you'll no doubt get the PowerPoint presentation as well and have that available to you. So this chapter is entitled Introduction to Data. We'll break this up into, I believe, 4 lectures. All of the lectures will be 15 minutes or less, and you can then watch them at your as you have the opportunity to do so, and then you can go on to do the homework out on Pearson Learning. So today we're going to talk about introduction to data. One of the things I love about statistics, and one of the things that got me interested in this topic from the very beginning when I entered my school years at BYU Provo, is the fact that these tools can apply to just about any type of endeavor, be it scientific or almost any others. There's going to be an element of data collection and learning how to interpret and understand that data. And that's what the science of statistics is all about. First of all, what data should we collect, why we would collect it, and then what we're going to do with it. But in just about any endeavor, that's true. When I went to work for DuPont many years ago, the very first study that I got involved in related to a product that DuPont had that they fed to chickens, and it was designed to fatten up the chickens so that they would bring more money and return to the to those who the chicken ranchers, if you will, those who raise the chickens. And they were thinking that this thing would work well with cattle as well as a cattle feed. And so we set up a nationwide study of dairy cattle to see whether or not this particular product would enhance the farmer's ability or the rancher's ability to gain more money after feeding him this product. And the product indeed showed that it had created milk that had a much higher fat content, which was indeed good for the farmers. And that was part of the marketing efforts that were had for that particular product. So just about any area of endeavor, the tools that we're going to be talking about are applicable. Today I shouldn't say today, but in these series of lectures on Chapter 1, these are the topics that I would hope you would feel like you understand when we get to the end. We're going to talk briefly about the science of statistics and define the science of statistics. Then we will talk about the concepts populations and samples. This is the most fundamental idea in the world of statistics, and I can't underestimate its importance. A lot of people make mistakes around this, as we'll show you in an example that we'll look at. We'll talk about just tabular summaries of data and some things that we can do to interpret those, and maybe when their information is missing, how to fill in the missing information. And then in the last section, we will talk about observational studies versus controlled experiments, 2 typical kinds of statistical studies that you will see out in the world. And to know the difference between those 2 is important because it impacts the decisions that you can make at the end of the day. So here is a definition of the science of statistics. This comes from something called the Encyclopedia of Statistics, which is intended to be an encyclopedia of all the different statistical tools that exist out in the world. Of course, new ones are being developed and all the time, as they are in any endeavor, so they would have to have addendums to that. But the statistics is the science of uncertainty. That's important because we can't always be certain in the decisions that we make, and thus there's going to be uncertainty involved. And we'll learn as we get into chapter 5, I believe it is, about probability, which is the language of uncertainty, and how that applies to the statistical tools and the analysis that we'll do. It's also the technology of extracting information from data. And so it's one thing to collect data, it's another thing to extract useful information from it. A few graphs will go a long ways, but also some additional tools. Some things don't require much sophistication. Just see a simple graph will do, but other things require more sophisticated tools. And this is just an introductory course, so we'll get into some tools, but others will be left to subsequent courses that some of you might take later on in your education. This is just an example of somebody trying to use statistics to draw a conclusion, and it's just a humorous example here to illustrate the point of extracting information. So here's an example of playing with data a little bit. Someone at some point decided they would look into this. They had an inclination to believe that maybe there was a difference in hurricanes depending on whether they had a male or a female name. Now, most of us would say I kind of doubt that, but the data has been dissected and used. And here's an example of, so this was 92 hurricanes. Back in the earlier days, this data goes all the way back to early 50s, like 1950 or so. And what they looked at was the death rate associated with hurricanes. And so what's shown on here are the number of deaths. We see the mean here is the average, which we'll talk about in our training. So this says that females have a higher average, on average 23.7, or around 24 people died per hurricane that had a female name, and on average 14 died per hurricane that had a male name. And the maximum you can see over there on the right, 256 versus 84, which that big hurricane there could definitely have affected that average. And on the bottom you see graphs of the death rates, the total number of deaths per hurricane. And you see that there is definitely some higher numbers there in general on the female named hurricanes. Now, does this mean cause and effect, that the name of the hurricane creates a different death rate? Well, we can't establish that with this, and we'll talk about that in the 4th lecture in this on this topic. But in any event, there appears to be something going on here. Some have speculated that maybe people aren't evacuating when the hurricane has a female name as effectively, and thus we have a higher death rate. Whether that's true or not, I don't think has ever been established, but it's interesting to look at data like this and start to see what kind of information it yields. And you see both from the table at the top and the graphs at the bottom that something is going on here anyway that could be further investigated. This is a question that all of you might ask at one point or another. Why do we care about statistics? Well, I care about it because I've made my profession in this world, but you as students should care about it because the applicability of these tools is tremendous, as I talked about earlier. They allow us to explore the world around us, use evidence to check whether our beliefs are true. I encourage you to read the very first story in our textbook about Florence Nightingale. It's a fascinating case study about using data to draw conclusions that is really well written in the textbook. It helps us to find patterns, to discover new things, and to share those discoveries with the rest of the world. Nearly every endeavor has got their academic journals and so on, and a lot of those journals have studies that have been conducted where they use the scientific method. They put forward a hypothesis, they collected data, and then determine whether or not that data supported the hypothesis that they made. Of course, statistics have to be used carefully. We're not here to just prove our point so much as to see what the truth is that we can extract from the data. And we'll talk about that in some of our discussions here. And certainly, if you don't use it correctly, you can draw inappropriate conclusions. And no matter what conclusions you draw, there's always some uncertainty involved. And we talked about how already that statistics is the language of uncertainty, in particular probability. We'll get more into that later on. Okay, so here's just an example. Two things that the textbook points out are major concepts associated with statistics. One is called variation, and the other is data. Well, data is kind of obvious in one sense that it's information that we collect on a subject of interest. Variation means that things change on us. You know, it's very interesting about that, even in the world of quantum physics, where it's dealing with the movement of the electrons around an atom. There's a certain amount of variation that's there, and it's very predictable, but the variation exists even down to that molecular level, if you will. And so understanding and coming to grips with variation, that's part of the uncertainty that we are dealing with, is an important idea. The hurricane plots, you saw that, of course, different hurricanes had different numbers of deaths, and there were more variation and the greater average with the female named hurricanes than there were with the male named hurricanes. For whatever reason, there's something going on there. In this word congratulations showing on the screen, you see that you don't see it at first, but when you point it out that the letters O, N, and T on that word actually have some variability associated with them, the way that they have been drawn up there. Of course, if you were drawing this up by hand in cursive, you would see the same thing. Your letters wouldn't exactly match all the time. Well, that's just the natural variability that exists in the world. So learning how to make decisions in the presence of that uncertainty is part of the science of statistics. Okay, so that's the idea of variation. As far as data goes, data is information, observation gathered so that we can draw conclusions. Now, context around that data is very important. Whenever I did a study as a professional statistician, I always asked about the background and what we were trying to show and what was the science behind it and so on. So if you look at the numbers that are on this screen, 832, 791, 964, and 10.33, those numbers don't mean a whole lot without some information about what do they represent, right? So the units, what are these measured in? Is this pounds or counts or some other unit? Well, the context matters. So it turns out in this particular case that this is data are the weights of newborn babies in some group of interest, and so now that puts it in context. And I think the unit here is pounds, although those would be pretty big babies for the most part. But now we have a little more idea of what these numbers represent, and so that's important. Not only is it just numbers, it's more about what they represent. So in data analysis, we're going to examine collected data to look for patterns, numerical summaries of the data, graphs, if you will, and try to capture the essence of what the data is telling us. In this particular case, we can see that the data is skewed. What that means is that there's a long tail on the high side and not much of a tail on the low side because you can't go below 0 deaths. And the median's about the same. They're about 6, but you see that there's a much more set of extreme observations with the female named hurricanes. For whatever that reason was the case, so the average was 24 versus 14, and the spread for the males' names that went up to 84 is the highest number, and for the females it was 256. All of that information is a nice, at least start of a summary of this data. There's obviously more that can be done, but we'll talk about that at some other time. So we're going to stop right there. I will move on to section 1.2 in the next lecture. And as always, I hope this has been helpful to you in digesting and understanding the first chapter, the beginnings of the first chapter of our textbook. Thank you. Now, if I can only figure out how to stop it.